distance formula today. Welcome back. Good to see you. Hopefully it's good for you to see me. We're going to talk about the distance formula and what it means to have some angles and things like that in the standard position. The distance formula. This should be a review. So we're going to say if point A, which has the coordinates x1 and y1, and point B, which has the coordinates x2 and y2. So we're saying in general, if they have these coordinates, so they could be any coordinates, positive or negative. We're just saying x1, y1, x2, y2. And they're points in a coordinate plane, and the distance between A and B is AB is equal to x2 minus x1 squared plus y2 minus y1 squared, and then we take the square root of that sum. Okay? Important things to remember about this process. We really have to be careful of using the order of operations to perform these functions. We have to make sure that we're doing parentheses first, then exponents, multiplication, division, addition, subtraction. Okay? So let's see how this works. This should be a bit of a review for you. Let's look at an example. How do we derive this? Okay? So a way that we could do this is we could say, let's go ahead and derive where this comes from. And so I've got the distance formula up here. I'm going to try not to cover it up. I've got the distance formula up here. And where does it come from? Really, where it comes from is having something in the coordinate plane that's going to help us use this. So let's look. If I have a squared plus b squared is equal to c squared, what I can say is I'm going to use this triangle. Now, I'm going to put a triangle in this coordinate plane. And it's going to be a right triangle because we're going to be using the distance formula. And so what I'm going to do is go ahead and draw this. And I'm going to say, in general, this is x1, y1. And in general, this is going to be x2, y2 up here. Okay? Now, we have a third point here. And that third point is related to the first point in that they share a y coordinate. So this is really going to be x2, y1. Because if you think, these are on the same level here. Okay? They're on the same level. And it shares an x coordinate with the second point because they're on the same level. Okay, now, really what we're asking is, what is the distance between each of these sets of points? The distance between point A and point C is going to be the absolute value, or we're just going to go ahead because we're in the positive quadrant. We're going to say it's x2 minus x1. Okay, so to find the difference between those. So if it was the difference between 4 and 1, it would be 4 minus 1 or 3. The difference between these two lines, or the distance between these 2 points here, is going to be y2 minus y1. The top one minus the bottom one. So if we go to find the length of the hypotenuse, which we don't know, which we'll call d, we're going to say d is equal to, now, using the Pythagorean theorem, d squared, hypotenuse squared, is equal to one of the sides squared, so x2 minus x1 squared, plus the second side length squared, which is going to be y2 minus y1, okay, squared. But if I want to find d, which is the distance between those 2 points, I'm going to say d is equal to the square root of x squared of x2 minus x1 squared plus y2 minus y1 squared. I use the Pythagorean theorem to solve for the length of that hypotenuse. So that's where this comes from. There's a little bit of an example. Now, the way that we use it is we just have different points. And we need to find the distance between them. So a good idea for you, finding distance, is equal to the square root x2 minus x1 squared plus y2 minus y1 squared. All of this is under the square root. It can be easy to confuse this with like the quadratic formula and the midpoint formula, things like that. Don't get them confused. We're talking about the distance formula here. So what I'm going to do is label each of these points. x1, y1, x2, y2. All right, here we go. I'm going to say distance is equal to the square root of, I'm going to give it a nice and big space, -1 minus 2 squared plus 5 minus 1 squared. Let's bring it down. Nice and big square root. -1 minus 2 would be -3 squared plus 5 minus 1, which is 4 squared. Bringing it down. Here we go. 9, because -3 squared is 9 plus 16 is equal to square root of 25, which we know to be 5. So the distance between these points is 5. Okay? Now, that's an example. In the next example, we're going to do a general outline of exactly what's going on here. Okay? If I wanted to say what is the distance between the origin, which is 0, 0, and the point xy, which is any point. So I'm going to find the distance between 0, 0 and any point xy. I'm still going to use the distance formula, and I'm still going to use a square root. But in this case, here's what I'm going to do. I'm going to go ahead and set this up in a way that gives me the most usable format. So what I'm going to do is I'm going to say this is x2, y2, and this is going to be x1, y1. So here I go. X minus 0 squared plus y minus 0 squared. What is that going to give me? It's going to give me the square root of x squared plus y squared. Now, really, a better letter for me to use is going to be r. Because when I use the letter r, now this formula might look familiar to you. Does it look like a circle formula? Because r squared is equal to x squared plus y squared is the circle formula, the formula for the graphing a circle. But right now, here's what I'm dealing with. This is a general form of the Pythagorean theorem that we're going to use to find the distance between 2 points. Okay, that's the first part. The second part is standard position. An angle is said to be in standard position. Standard position is good. That's where we're going to start from. It's said to be in standard position if the initial side is along the positive x-axis and its vertex is at the origin. What does this look like? When we talked about angles the other day, we talked about how we're going to call them theta. Well, if we have a theta here, and I'm going to use the arrow to show how it opens, the bottom of theta is going to be the positive x-axis. This is going to be standard position. Going to be like 3 o'clock. The vertex is at the origin, so that's 0, 0 here. Okay? And we've got an angle in standard position. Now, if, say, this opens up, and we've got the terminal side, okay? The terminal side. So, if you'll recall, when we say the initial side, we're talking about where it comes from. So this is the initial side. And the terminal side, if you want to think about it as the side that's actually moving, so that's the hand that's going around, because the initial side stays put. It's stuck right there. But the terminal side is the part that's going to move until it gets to the required amount of degrees and stop. The terminal side, if it's in quadrant 1, we would say that theta, the angle, and we're going to do a fancy little E like this, and we're going to say it's in quadrant 1. Okay? If the terminal side is in quadrant 2, say in this green angle here, we would say that theta is in quadrant 2. Okay? So that's standard position. We're assuming that we're starting from 3 o'clock or from the positive x-axis, and we're going around and around in a counterclockwise fashion. Okay, angles. How do we talk about angles that are actually on the quadrant lines? A quadrant angle is one of the axes. So positive x, positive y, negative x, negative y. So here's what it looks like. Say, for example, I've got my terminal side here. Okay, so my terminal side is here. If there's no other angle, then I would say that this is a 0-degree angle. Okay? If I go up and down, I'm having problems with color choice here. We'll go pink on this one. If it's up and down, and it stops right there, so we're saying this is theta, and that's going to be a 90-degree angle. Okay? If it opens up this way, and it's along the negative x-axis, we're going to say this is a 180-degree angle. Because notice, how far has it opened? It's opened halfway around the circle. And for the last one, we'll use a little bit of orange here. Okay, if it goes around this way, this is going to be 270 degrees. Okay? Now, I am able to keep going around and around and around. Notice how far I've gone. I've gone 270 degrees all the way around. But what if I went another 90? And so then I would have something up here that would be 360, right? If it's 360, it's on the same thing as 0. It's on the same axis as 0. So for example, things that are on the same axis are called coterminals. So for example, 0 degrees and 360 degrees would be coterminal. They're angles that fall along the same axis. They fall on the same quadrant angle. Okay? So then 360 plus another 90, this 90 up here could become 450. Okay? And so what we're doing here is we're going around and around, around and around. We can have thousands of degrees, millions of degrees, but if they fall on the exact quadrant lines, we're talking about coterminal angles. They're going to share the same degree measure, but they're not the same exact angle. They have different angle measures. Okay? Something else. Look at what happens here. What if I was rotating this way, and I had an angle that came down and was on this orange right here? Well, if I was rotating backward, so rotating backward, that would be a negative 90 degrees. So negative 90 and 270 are also coterminal angles. So I can continue to go around and around in a negative way that way. Okay? Thanks for watching. We'll see you tomorrow.